belong to college algebra. I'm gonna teach you consequences of the field axiom. So actually this topic is just explain some concepts, some rule, some laws for the real numbers. Okay, we have 5 different rules, 5 different properties that we are going to apply in the college algebra in the future. So here I'm going to show you what are of those rules as law or property for the real numbers. So then the consequences of the field axioms actually is of the axioms. Remember last time we teach we learning how the meaning axioms and definition are called theorems. So the theorems is actually all these as a theorems, right? For the real numbers, we have one theorem, like for example, when for all real numbers, a, b, c, when you have a equals b, then a plus c is going to be b plus c. This is called addition property of equality. We have on the second one theorem, so multiplication property of equality. For example, you see, or you have a equals b, then a times c is equals b times c. All right, this is called multiplication property of the equality. We have another third one, multiplication property of 0. When you multiply, for example, a times 0 is equals 0, or 0 times a is equals 0, right? We have another theorem, is the number 4, double negative. The double negative is when you, for example, multiply negative times negative a is going to be a positive a. You multiply, for example, negative a times negative b, the answer is going to be positive ab, right? Okay, that's theorem number 4. Theorem number 5 is equality test for all real numbers. You have, for example, a divided by b must be equals d divided by c. If ac is equals, or I mean a times c is equals b times d, right? That is okay. Our exercise here, we have some 6 problems actually. You have to be able to write with theorem. With theorems apply for each kind of problem. The first one, we have negative a times negative 3 equals a times 3. What is the property? What is the theorem we will apply? So we are talking about which one? We are talking about the number 4, double negative. This one is applied for double negative. Double negative theorem, right? So we have a second problem. 80 times 0 is equals 0. With which property apply here? Which property apply from the property that I tell you just 18 times 0. So you take a look, you see, for example, number 3, multiply property of 0. This is a theorem property of 0, okay? Multiplication property the 0 of 0 of 0, right? So number 3, you have negative 4 third equals 4 divided by negative 3. Which property you're talking about? So you take a look at the properties. Also you have the property number 4. We confused right here. This is number 4. So you have the property number 4. Yeah, it's a double negative too. Right here, it's a double negative property, right? So double negative property, or the theorem. These are called theorems. So right. So and then we have one more, number 4. Question number 4. Negative k divided by negative 9 equals k ninths. Which property apply from this? So you have again the double negative property. Double negative property, right? Or the theorem number 4. So number 5. Number 5, negative 9 times r equals negative I times r. It's the same thing. So again, it's the same property, double negative property. So double negative property. I mean the theorem double negative property. So the last one, you have 1 divided by x times 1 divided by y equals 1 divided by x times y, x times y. Which property are you talking about? So you see the number 5, the equality test for all real numbers. Equality test for all real numbers is this property. So equality test, the last one is equality test for all real numbers. So that all real numbers. All right. So this is the topic for today. We are gonna try to understand what I mean the consequences of the field axiom. So you have the axioms is calling in the algebra theorems. When you have a theorem, it's a property. So apply these kind of properties for addition, for multiplication, for example, this multiplication property 0, property of equality, equality test for all real numbers. So we have different kind of properties, different kind of theorems. Those theorems apply in different kind of the problems, like this exercise where you have right here. So when you solve those problems, you need to be able to understand which property, which theorem you are applying in each one. Okay, so